Now we're going to do the same thing on a unit circle, but with our 45, 45, 90 special triangle. So let's draw the 45, 45, 90. Notice that both sides are 1, both legs are 1, so 1, 1, and the hypotenuse is the square root of 2. Now if I want to create a similar triangle that has a radius of 1 or a hypotenuse of 1, I'm going to have to divide everything by the square root of 2. So if I divide by the square root of 2, the hypotenuse now is the square root of 2 divided by the square root of 2, which would just be 1. The two legs are both 1 divided by the square root of 2. Still a 45-degree angle on both of those angles, but we've scaled it down to fit inside the unit circle. Now it's important to know what the square root of what 1 over the square root of 2 equals, and if you did this on the calculator and got a decimal approximation, it's about 0.71. So about 0.7 when we're graphing. Something else that I want to point out is that on the unit circle, and you'll see this why in the next video, the pattern that occurs, usually the 1 over radical 2 is written in rationalized form. By rationalized form, I mean that we're multiplying the numerator and the denominator by square root of 2. When we do that, the numerator becomes square root of 2. The denominator is square root of 2 squared, which is just 2. So square root of 2 over 2. So this square root of 2 over 2 is equivalent to 1 over square root of 2. They both equal 0.71. They're both the same number. But this is the one that you'll see used on the unit circle. If you see it ever published in a textbook or referred to, it's almost always written as square root of 2 over 2. So that's the way I'm going to write it, but realize that's the very same thing as 1 over square root of 2. It's just the sine or cosine value for 45 degrees. They're both the same, since those two legs are both the same. So when we do this triangle, you'll see that both the x and the y values are about 0.7. So these are both 1 over the square root of 2, or square root of 2 over 2, or 0.71. Okay, so same thing here. Both of these sides are the same. So I'm just going to write square root of 2 over 2 here. So at a 45-degree angle, I'm going to write 45 up here. The coordinates are positive square root of 2 over 2, positive square root of 2 over 2, are about 0.7, 0.7. So pretty close to 0.7. Now we're going to go and do the same thing we did for the other quadrants. So when we do the same reference angle in quadrant 2, this would correspond to 135 degrees, because 135 plus 45 would give me 180. The only change in the coordinates is that the x coordinate becomes negative, so it's negative square root of 2 over 2, positive square root of 2 over 2. When we go down to quadrant 3, then I'm going to write these on here, negative square root of 2 over 2. Now both values are negative, so this now, the y value becomes negative as well as the x value. Since this is 45 more than 180, this corresponds to the angle 225. And so if we go ahead and label these two, they're both negative. Negative radical 2 over 2, negative radical 2 over 2. Going into quadrant 4 at a 45-degree angle, this corresponds to 315 degrees. And now the x value has become positive again because we're headed in the positive direction for the adjacent side, and the y value remains negative. Now I want to add one more set of coordinates to this graph. I want to look at the coordinates for 0, 90, 180, and 270. So here's 0 degrees, 90 degrees, 180 I already wrote, and 270. And I'm going to move 180 over a little bit just to get it out of the way so I can put the coordinates of the points on. Now remember, this is a unit circle. It has a radius of 1. So when I go out to the point at 0 degrees, I'm going out 1 in the x direction, but I'm not going up and down at all, so the y direction would be 0. So this is the point 1, 0. When I go up to 90 degrees, then I have the point 0, 1. 0 adjacent side, 1 opposite side. When I go over to 180, my x is negative now, so negative 1, 0. And when I go down to 270, my y is negative, so 0, negative 1. Now recall that I can use the cosine value, or use the x value to tell me cosine, and the y value to tell me sine. So this would be cosine of 45. This would be sine of 45. They happen to be the same. If I go to 0 degrees, this would be cosine of 0 degrees. This would be sine of 0 degrees. Okay, so if I wanted to find cosine of 90, for example, cosine of 90 would be 0. Sine of 90 would be 1. Cosine of 135 would be negative square root of 2 over 2. Cosine or sine of 135 would be square root of 2 over 2. Sine of 180 would be 0, and cosine of 180 would be negative 1. Okay, so let me just write down a few examples here then. So I could say cosine of 225, I would look at this x value, equals negative square root of 2 over 2. And that's the same as negative 1 over square root of 2. Same thing, same number. I could say sine of 270 is equal to 1. Now what about tangent? Let's recall that tangent of theta is equal to opposite over adjacent. In this case it would be y over x, because the y is the opposite side, the x is the adjacent side. So if I wanted to find tangent of 270, for example, I would do negative 1 over 0, which happens to be undefined. And we talked in a previous video about the fact that tangent represents slope, and the slope of a vertical line is undefined, and there is a vertical angle. This angle is completely vertical when I'm at 270 or 90. Okay, we're going to stop here and then put it all together in the next video.